Good morning and welcome to Pre-Algebra with Miss Betsy. We are in section 11.4 of our chapter on geometry, and today we're going to be discussing parallel lines. If you're using my text, I am using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I am in the first edition on page 361. Before I get started, I've got a story to read for you. In a small town, the veterinarian, who was also the chief of police, was awakened by the telephone. "Please hurry," said the woman's voice on the other end of the line. "Do you need the police or a vet?" he asked. "Both," the woman replied. "I'm not able to get my dog's mouth open and there's a burglar's leg in it." So that's pretty good. See, I've already got some stuff drawn on the board yet again. Last section we talked about perpendicular lines which intersect at a right angle. Today we're talking about parallel lines. And parallel lines are two lines that will go on forever in either direction, but they never cross, they never change. It's like the theoretical, when a railroad track is constructed correctly, if it went on forever, the two rails of that railroad track would never cross. They'd never intersect, or else your train wouldn't be able to run on it. So that's what parallel lines are. And we use two vertical marks, looks like two capital letter I's, to indicate that line AB is parallel to line CD. And what we're going to do now is we're going to take another line, we're going to draw this line across our two existing lines so that it intersects both of them. And this line that goes through here has a fancy name. It's a transversal. Just a line that goes across other lines. That's a transversal. And when you take two parallel lines, line AB and line CD, and you intersect them with a transversal, you see that you have a bunch of different angles that are formed. You have 8 angles, don't you? The first line where they're crossed, you have 4 angles, and at the intersection of the second line by the transversal, you have 4 more angles. And we're going to go ahead and continue throwing definitions at you that you will need to know. Let me make sure I get these angles labeled right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Angle 5, 6, 7, and 8. And there are 3 different types of relationships between the angles. You have alternate exterior angles, you have alternate interior angles, and you also have corresponding angles. These are the relationships that are between them. Let's think, what might alternate be? Well, alternate angles would be across the line from one another on the outside. Alternate exterior angles, alternate interior angles. Because my little chart here, we're talking about interior angles first. What do we have? Well, here's an inside angle, and here's the angle on the opposite side. These are angle 3, and angle 6 would be a pair of alternate interior angles. The alternate means that, see, it's on the opposite side of the line, angle 3 and angle 6. And they are the same, alternate interior angles. The measure of those angles is the same. So the measure of angle 3 is the same as the measure of angle 6. Do Do you see two more pairs of alternate interior angles? Yeah, angle 4 and angle 5. They're the inside angles. They're the angles inside the railroad tracks across the transversal. So their measure, the measure of angle 4, is the same as the measure of angle 5. So the definition that you have to know here, you have to understand alternate angles. They're on the opposite side of the bisecting line. And you have to understand interior, that they're the angles within the railroad tracks, if you will. And you need to know that the measures of alternate interior angles are identical. So that's going to help you. If you know that the measure of this angle right here is 120 degrees, you know that the measure of angle 5 is going to be 120 degrees also. That's going to be real important with your geometry. Now, what do you think alternate exterior angles might be? Well, yeah, we're looking at the angles on the outside of the railroad track. The exterior angles are angles 1, 2, 7, and 8. And your alternate exterior angles are going to be on the opposite side of the transversal on the outside of the railroad tracks. So you have the measure of angle 1 is the same as the measure of angle 8. And what are you seeing here? You're seeing that alternate angles are equal. The measures of alternate exterior angles and the measures of alternate interior angles are the same. So we have the measure of angle 2 is going to be the same as the measure of angle 7. You simply have to be able to learn to identify these. And then finally we have corresponding angles. And let me go ahead and read the definition of this corresponding angles. Corresponding angles, angle 1 and angle 5. You have pairs of corresponding angles. You have two lines that are connected, two lines that are parallel to one another. When you cut these by the transversal, wish I had a red marker right now. When you cut these by the transversal, they're the angles that are in the same relationship to one another. Angle 1 and angle 5, these are corresponding. So you have the measure of angle 1 is the same as the measure of angle 5. What other corresponding angles do we have? Well, how about if I do a double mark there? Do you see that it's the line that is being crossed by the transversal? It's the lower left-hand corner angle. So those are corresponding, and you have the measure of angle 3 is the same as the measure of angle 7. And then we have two more pairs of corresponding angles. Angle 2 and angle 6. 1, 2, 3. You have the measure of angle 2 is the same as the measure of angle 6. And what's our fourth pair of corresponding angles? Angle 4 and angle 8. Measure of angle 4 is the same as the measure of angle 8. And there's nothing that I can tell you to do about this, about how you calculate anything. You simply have to understand you have two parallel lines cut by a third line, which is called a transversal. And then you have to understand alternate interior angles, the relationship between the angles inside the railroad tracks, alternate exterior angles, the relationship between the angles on the outside, and corresponding angles, the ones that are in the same relationship to one another. You understand those and your work is done. Let's go ahead and do an example problem here. I think probably just easier to go ahead and erase that to begin with. So we have two parallel lines that are intersected by a transversal, and we want to be able to see the relationship between angles here. And we are defining these two lines to be parallel: 10, 9, 8, 7, 6, 5, 4, and 3. Here's our sketch, and they're reviewing your vocabulary. They say, use the figure to identify the following angles. And it says, angle 9 and what angle are alternate interior angles? Angle 9 and angle 4 are alternate interior. Do you see why this is? They're within the railroad track on opposite sides of the transversal. 9 and angle 4 are alternate interior. Angle 7 and what angle are alternate exterior? Alternate exterior, they're the angles outside the railroad tracks on opposite sides of the line. So angle 7 and angle 6 have to be alternate interior. I'm sorry, alternate exterior. The next question says angle 10 and what angle are complementary? What are, I said, complementary? It's a C word. See, the vocabulary is important. What are complementary angles? Complementary angles are two angles that have the sum of their measures is 90 degrees. Corresponding angles are what we're talking about today. They're in the same relative position. So angle 10 is top left. Angle 8 is top left. So angle 10 and angle 8 are corresponding. And then angle 3 and what angle are corresponding? Where's angle 3? Lower right angle of these four. The lower right angle is angle 5. So that's what these problems are going to be. They're going to show you a sketch and say, do you understand alternate interior, alternate exterior, and corresponding angles? And then, once you have that, they're going to put the information about interior, exterior, corresponding angles, complementary, supplementary, vertical, and adjacent angles together to help you to let you see that you can come up with the measurements of angles if you're given simply the measure of one, and you don't have to use that protractor to read off the measure of an angle, because that's never going to be exact. So let me do one more sketch here. And we're saying that these two lines are parallel, and they'll tell you in the book, they'll say this line and this line are parallel, or this line and the other line are perpendicular. So you are never going to be expected to look at a drawing in geometry and say, oh, well, that has to be a right angle. They will tell you if it's a right angle. They will tell you if the lines are parallel. They will tell you if the lines are perpendicular. So let's see what information we have. We have angle 1, we have angle 2, we have 110 degrees, angle 3, and angle 4. Why didn't they put the other angles in? Because we don't care about them. They're not going to ask you any questions. But what you have here is you see that only one measurement has been given to you. And the question says, find the measures of angle 1, 2, 3, and 4. Find measure of angle 1, the measure of angle 2, the measure of angle 3, and finally the measure of angle 4. So you're going to have to use the information that you have gained, the definitions that you've gained in this chapter thus far, to be able to come up with the solutions to this problem. So let's see, what do we know? Angle 1, well, we can look at angle 1. These are vertical angles. Remember, vertical angles are opposite one another, and they have the same measure. So the measure of angle 1 has to be 110 degrees. What about angle 2? Okay, angle 2 is supplementary to angle 110, isn't it? Let's see if that's what they pulled out. Yes, they're on a straight line. Supplementary angles, their sum is equal to 180. So the measure of angle 2 plus 110 degrees has to be equal to 180, doesn't it? So what does that tell us? That the measure of angle 2 has to be equal to? Well, you can calculate it if you need to, subtract 110 from both sides. But you see that the measure of angle 2 is 70 degrees. Now, what do we know about angle 3? Okay, well, we can say angle 3 and angle that's measured 110 degrees, they're inside the railroad tracks, aren't they? They're on opposite sides of the transversal, so those are alternate interior angles, and they have the same measure. So the measure of angle 3 is also 110 degrees. And our final measure, angle 4, these are corresponding angles. This is the bottom right-hand side. This is the bottom right-hand side. Corresponding angles have equal measures. So angle 4 also has to have a measure of 110 degrees. This is the type of information that you're going to be working with and learning to manipulate, learning to figure out measures of degrees of angles based on the definitions that you've learned here in geometry. So enjoy those, and I'll see you next time.